All right, this video is on dilutions, so it's a continuation of our discussion on molarity, concentrations of solutions, but in this video we'll focus specifically on what it means to do a dilution, how to mathematically calculate the information to do a dilution, and then what actually is involved. So if you think about the word dilute, or to dilute something, I'm sure most people know that to dilute means to add water. Okay, so to start this discussion, let's say we have a beaker that has some amount of water in it, and we'll pick NaCl because it's our favorite, and I dissolve the NaCl in the water. So of course now I have a solution, and if I had enough information, I could calculate the molarity of that solution, and it would be a known number. You know, maybe it's 1 molar, maybe it's 1.5 molar. Stuff like that. Okay, so then if I wanted to dilute it by then adding more water, let's talk about what would change. So I add, more water, okay? So what has changed in this beaker? Well, adding water changes the total volume of the solution, right? It went up. So, maybe I had 50 mils in there and I added, 15 more mils. So of course the volume of the solution increased and the molarity of the solution decreases, right? Because there's more water. Okay. What doesn't change though are the moles of NaCl. Okay, and that's an important point, and it's that point that then allows us to derive a formula that we can use to perform dilution calculations. So kind of think about it. If you have that beaker of water and you have NaCl in there and you add more water, well, you're not doing anything to the NaCl. However many moles were in there to start with are still in there after the dilution. So from that, we can say the moles of solute before the dilution are equal to the moles of solute after the dilution. Okay, that's kind of what we just said, that the moles aren't going to change. They're going to stay the same. From there, let's think about that we know molarity is moles per liter, right? So if I wanted to solve that equation for moles, then I would have moles equal to molarity times liters, just like we did in our discussion of molarity. So then I can kind of substitute that in. Well, if my moles of solute, right, are equal to liters times molarity, well, then this quantity, whoops, that was bad, is equal to molarity before times liters before, and then molarity after times liters after. Okay, so what I have done is I've just said, well, if moles are equal to molarity times liters, then I can substitute that information in. And that's great. We don't love writing the word before and after because that takes time. So we decide instead of before and after to use the subscripts 1 and 2. And then instead of liters, because it doesn't actually have to be liters, it could be milliliters. We come away from liters and call it volume. So our formula becomes M1 times V1 equals M2 times V2, and this is the dilution formula. It probably doesn't mean much to us right now, but we're going to see how to use that in an example problem in just a minute, and then we'll talk about how that number we solve for then can be what you would do with that, like in the laboratory setting. Okay, so here's my example. How many milliliters of a 3 molar H2SO4 solution are needed to make 450 milliliters of a 0.1 molar H2SO4 solution? Okay, so I'm going to draw a picture because I think it's the easiest way to explain this. So let's say I have my beaker. This is my 3 molar H2SO4, which we actually are going to refer to this as the stock solution. That's the one that like you're working with. It's the more concentrated solution. Okay, it's called the stock solution. So our question that we're being asked is how many milliliters of this solution do I need to take out of that container, put into a new container that eventually will be 0.1 molar and 450 mils total. So we're going to solve this with M1 V1. Okay, so just like any other variable equation, I have 3 pieces of information and I'm looking for the 4th, but we have to be very careful in where we put these, how we classify these. Okay, so let's see. Let's talk about what we're looking for first. So I'm looking for the volume. So I'm looking for V, right? And it really doesn't matter. You can call it V1 or you can call it V2. You just have to make sure that we call the matching concentration or molarity the same number. Okay, so I'll call it V1 since it's before the dilution, which means that, so now I'm talking about how much volume of this solution do I have to take out. So if I'm talking about this solution and I've called this V1, then this number must be M1, because do you see how they match? It's the volume of this solution of this concentration. So then, of course, that would make these two M2 and V2, right? So I'm looking in this case then for V1. Okay, so I would solve this for V1, dividing both sides by M1. And from here, all I have to do is plug in my numbers, right? V1 is equal to M2, which is 0.1 molar, times times V2, which is 450 milliliters, over M1, which was 3 molar. And if I do this math, watch your units, your molarities cancel, leaving you with milliliters. Hey, that's what I wanted, so it works out perfectly. We get an answer of 15 milliliters. And that's my mathematical answer. Like, that would be the multiple choice answer that the test would want you to circle for this problem, okay? And that's great. But there's that one step past this, which is what does this mean? And then how would I actually create this dilution? Okay, so what you just solved for was how much of this stock solution do I need to take out and put into my new container? And now we know it's 15 milliliters. Okay, so to actually perform this dilution, you would take 15 mils from the stock solution and place it into, or put it into a flask. We'll talk about this when we do the lab about specific glassware and all that. So we would take exactly 15 milliliters from this stock solution and put it into another piece of glassware. Okay, so here I go. There's my 15 milliliters. Now at this point, I want you to think about something. If all I have done is taken 15 mils from this and put it into this container, what's the molarity of this solution in this container? Okay, and it's not a trick question because, well, maybe it kind of is. The answer is it's the same as this molarity, right? It's 3 molar. I haven't done anything yet. All I've done is poured some of it into this container. So right now, my concentration is still 3 molar. I have to now add the water to perform the dilution. And a lot of times I get students who say this, and it's technically correct, but it's the wrong way to think about it in terms of chemistry. I know my total solution needs to be 450 mils. I know I'm putting 15 mils of the stock into here. So students will say 450 minus 15 is 435. I need to add 435 milliliters of water to the beaker. And that's technically correct, but that's not how we're going to think about it. What we're going to say is that we're going to add water until the total volume reaches 450 milliliters. Okay, so what you would do is you would get your container of distilled water and you would come and you would add enough water, right? I don't care how much it is. We would add enough water until this total volume was 450. We would stir it. We would put a label on it that says 0.1 molar H2SO4. Okay, and so I know what you're thinking is that, well, that's still adding 435 milliliters of water, and technically that's correct, but that is not how we think about it, okay? And it's not how we think about it for several reasons that we'll talk about later. So that's a dilution. That's the calculations behind the dilution, and that's physically how you would perform the dilution if you were asked to do it in the lab setting.